Welcome back to the course Engineering Chemistry. Myself Dr. Harika, Assistant Professor, Department of Chemistry, MLR Institute of Technology, Hyderabad. In previous class, we have discussed about the factors influencing rate of corrosion. What are the various factors influencing the corrosion, like nature of metals, nature of the environment. In today's class, we are going to discuss about the corrosion control methods. Let us see the corrosion control methods. We have chosen one of the corrosion control method is sacrificial anodic method and impulsive current cathodic protection. These two comes under cathodic protection. Corrosion control methods nowadays we are using the mainly is sacrificial anodic method and impulsive current cathodic method. These two comes under cathodic protection. First of all, let us know what is meant by cathodic protection. Actually, a metal is more prone to based on the surroundings of the atmosphere, it is more tendency to lose the electrons. If we take any water pipeline, buried water pipeline or oil pipeline, gas pipeline, it undergoes corrosion fast because of the minerals, metals, moisture, bacteria, and what are the other constraints present inside the soil. So, these are the metals will undergo corrosion very fastly. How to protect these buried pipelines? So, actually these buried pipelines act as anode. If they behave as a cathode, they were protected. If it acts as anode, it gets corroded. So, we have to convert these they have to behave like a cathodic material. So, we have to force them to behave like cathode. So, cathodic protection is nothing but forcing the metal to be protected to behave like a cathode. It should behave like a cathode by applying external materials. Let us know the first cathodic protection is sacrificial anodic method. The metallic structure is connected by a wire to a more anodic metal which slowly gets corroded. If there is any pipeline, if you want to protect this pipeline which is buried below the soil, not to protect this pipeline, so we have to connect through a wire to the more anodic metal. So the metallic structure is connected by a wire to a more anodic metal which slowly gets corroded. So, to which metal we have to connect through a wire? If we see, this is a galvanic series, we know that. The galvanic series tells about the increasing order of the reduction potential. The metals which are at the top having more tendency to lose the electrons and the metals which are at the bottom is more tendency to gain the electrons. Or it is having a more reduction potential, the metals at the top is having more oxidation potential. So, in order to protect a metal like iron, it should be connected through a wire to the more anodic metals, where the anodic metal gets corroded. So, the metal structure is connected by a wire to the more anodic metal which slowly gets corroded, while the metallic structure acts as cathode and it is protected. If we see this diagram, this is a pipeline, water pipeline or any pipeline which is under the earth's surface. So, without magnesium anode, this is the pipeline gets corroded very fastly because of the minerals, metals, alloys and other moisture, bacteria which are present in the soil. In order to protect this pipeline, we have connected through a wire. This is a copper wire. Insulated copper wire is connected to the more anodic metal. So, all the corrosion current lies here and the magnesium blocks gets corroded. Why I have chosen the magnesium? Because when compared with iron pipeline or stainless steel pipeline, magnesium is more anodic than the iron. If we see this galvanic series, so magnesium, zinc, aluminum, low carbon steel, iron. If the pipeline is iron pipeline, so the metals above we can use as an anode. This metal gets corroded very fastly when compared with the iron. This is an order where we are going to arrange the metals and alloys in increasing order of their reduction potential. This is called galvanic series. Based on the galvanic series, we can choose a metal which acts as an anode. Here the more active metal so employed is called sacrificial anode. So, in order to protect the base metal, what is meant by base metal? Here the pipeline is a base metal. The metal which is to be protected from corrosion is called base metal. So, in order to protect a pipeline which is called base metal, so we need a sacrificer which is also called as sacrificer anodic metal. See here the more active metal so employed is called sacrificial anode and is replaced by fresh metal once it is totally corroded. So, the base metal is connected to a more anodic metal such as magnesium or aluminum or zinc or any other alloy. So, all the corrosion takes place at the magnesium. If the metal is corroded completely, the magnesium should be replaced with new magnesium block. If we won't replace, all the corrosion takes place again to the base metal. Commonly used sacrificial anodes are magnesium, zinc, aluminum and their alloys. This is applied in the production of buried pipelines, underground cables, marine structures, ship hulls and water tanks. We know that ship sails in the salt water, in the oceans and seas. So, the ship hull is made up of stainless steel or steel. So, in order to protect the ship hull, we are going to place a zinc block or a magnesium block which is connected to a insulated wire. If you see this picture, the ship hull is protected with the help of the zinc block or magnesium block which is sailing in the water, which is connected through insulated copper wire. One more example is water tank. If you see this water tank or a boiler, if it is having full of water or the half of the water, we know that the corrosion just takes place just below the water level. Just below the waterline corrosion, it takes place. In order to protect the boiler or metals or tankers from corrosion or waterline corrosion, so a copper wire is connected and a magnesium block was hanging into the water or zinc block. So, all the corrosion takes place at this magnesium block or zinc block. Therefore, the water tank is protected from the corrosion or waterline corrosion. So, here the sacrificer is more anodic metallized zinc and magnesium. Always we have to replace, when it is corroded completely, we have to replace with a new one. Let us move to the next cathodic protection is impressed current cathodic protection. Here, in this method, we are going to apply the external source. We are going to apply the external source. In this method, an impulsive current is applied in opposite direction to nullify the corrosion current. Always the corrosion current, if you see this picture, this is the underground buried pipeline or gas pipeline or water pipeline. In order to protect this metal from corrosion, so we have to supply external current. Here the source is battery or any external source which is connected. The negative terminal of this battery is connected to the pipeline and the positive terminal is connected to the more anodic metal such as sacrificer. In this method, an impulsive current is applied in opposite direction. Actually, corrosion current takes place on this pipeline. In order to nullify that corrosion current, we are going to supply the impulsive current from the opposite direction. To nullify the corrosion current and convert the corroding metal from anode to the cathode, by supplying the implicit current just a little amount greater than the corrosion current to this pipeline. See the electrons, this is the anodic metal which releases the electrons. The electrons moves from this side to this side. Without this battery and anode, this is the pipeline which is called base metal acts as anode. When we connect it to the more anodic metal and a battery, this acts as a cathode. So we made this to behave like a cathode. So actually the corrosion current takes place and this is the base metal gets corroded. The corrosion current should be nullified by supplying an external current called DC current by using a battery or any energy source. The implicit current is derived from direct current source. With an insoluble anode like graphite, we are going to use the anode like graphite, high silica iron, stainless steel or platinum. A sufficient DC current is applied to an insoluble anode buried in the soil and connected to the metallic structure to be protected. So, if this is a pipeline, we have seen this. This is a battery, energy source, neutral terminal, positive terminal. To the positive terminal, we have connected to the anodic metal. This is the anodic metal. This is the base metal which is to be protected. A sufficient DC is applied insoluble anode. Therefore, the electrons moves from anode to cathode. Therefore, the base metal is protected. Used in production of open water box coolers. These are mainly used in production of open box water coolers, buried oil and water pipelines which are submerged in the seas and oceans, transmission, line towers, light-up ships, particularly useful for large structures for long-term operations. So, which is continuously running and which is used for many years, such as pipelines, and whose lifetime should be increased. Therefore, we are going to use these methods. The implicit current cathodic protection is more superior than the sacrificial anodic protection. So, for long structures and large structures for long-term operations, implicit current cathodic protection is most suitable. Summary. In today's class, we have discussed about the cathodic protection. Cathodic protection is nowadays, it is one of the corrosion control method. Among these, one is sacrificial anodic protection. In this, the pipeline which is connected to the more anodic metal which is active. The metal which is to be protected from corrosion, which acts as cathode, it is connected to the more anodic metal, therefore all the corrosion takes place here. And the second one is impressed current cathodic protection. Impressed current cathodic protection. In this, the base metal is connected to a more anodic metal through a DC current, DC power source. Anode. The anode is made up of stainless steel which is buried in gypsum or any other. So, the released electrons from anode to it will move towards the cathode, nothing but base metal. Therefore, it acts as a cathode and it gets protected. Thank you.